Today what all I discuss, they are not numericals. They are just the basic fundamentals of a spring. Of course, in books open, we just say spring force, conservative force, U equal to kx squared by 2 will wind up. But the concepts are hidden in numericals. Now, here, what is the condition given for us? The block. So I'll pull the force. So what is if when the spring will get elongated? Only when the applied force, at least it should overcome the friction, no? Mu m1g. Let mu be the friction here. First, when the block m1 will start shifting, when the applied force overcome the friction. So I applied a force where, and what is the initial state of them? Rest that one. So I applied a force. Then from rest to rest, it got shifted. Then I applied a force such that I'm able to overcome the friction, mu mg. Then what about the spring force? Spring force will act like this. And here the spring force. Now this spring force, can it shift m2? So when the spring force m2 will shift it. Only when the spring force is greater than, is able to overcome the limiting friction mu m2g, that one. Here, what is the state of m1 when we are doing that one? I'm pulling it from rest to rest gradually. I'll apply force, m1 not moving. Again, I'll increase force. Now I apply force which is just greater than limiting friction. Then the block m1 shifts. As it starts shifting here on the LHS, what happens? Spring force will increase, no? So this force now, together these two will balance. And what is the state of m1? M1, what happened? Will come to rest here. So from rest to rest, I'll be moving. Gradually, I'll increase force. Then I'll see that m1 will shift. Again, like this. So the block m1, what happened? Will be pulled like this. Not like sudden. I'm not increasing sudden. So therefore the condition put constant horizontal force means I'll apply force. M1 will not shift. Then I'll increase the force. Then when F greater than mu m1g, m1 will shift. As it starts shifting, the spring force will increase. So what will happen to the block now? So from like a motion, what happen? It will come to rest here. Then I'll check it. The spring force greater than mu m2g. No. Again, I'll move the block from rest to rest. Then again, I'll check the spring force. Is it able to overcome? So this sequence is what? It is taking place here. So let's take this one. So when block M2 shifts.
Sir, can you repeat what you have just said, sir?
Here, the M1, what will happen? I will shift like this. To shift it to happen, at least I should apply force greater than mu m1g. So I applied a force greater than mu mg. So from rest, I'll bring like this. Then when I shift it by distance x, then the spring force, how much will act kx? So what is the state of m1? That's what we have to ask ourselves a question. The state of m1, what happened, will be at rest here. Sir, how come you applied force? Yes, I applied a force greater than mu m1g. As the block starts moving, spring will get elongated. So then here what happened? The block, what happened, will undergo retardation and it will come to rest here. Then I'll check the kx value. What is the kx? Is it greater than friction? No. So what again I do? It's at rest. Again, I'll further shift it. So what is the state of M1? How I'll be moving from rest to rest? Means not like sudden, gradually.
Sir?
Yeah.
So you're saying you're moving that block slowly, right? Like acceleration is almost zero.
Better you say gradually. So yeah, the sequence, what happens is like this. Look at the spot how I'm moving. It'll be like this. Then one value of F at which it will, this block M2 will shift. Fine here. So that's what that minimum is asking. So I have to search that minimum like this. So what happens if block M1 accelerates, it will not become minimum. Are you getting now? Then you are going to write the equation like F minus Kx minus mu M1g equal to M1A. So definitely the force will become greater value. So therefore, since he has asked minimum, no. So therefore, when M2 is about to shift, what should be the state of the block M1? Should be at rest. And anyway, this is about to shift, no. So block M2 shifts when Kx greater than mu M2G. So that this word having a lot of weightage. Block M2 shifts, this is the thing. So here, now what about the force? External force, will it do any work? Is work done by external force, F into dx. Then work done by frictional force, mu m1g dx. Work done by spring force, kx dx. It was at rest. Finally, it is at rest. Initial kinetic energy, or we'll do one thing. Ki. So what is the initial kinetic energy? That will be 0. F into x. So solving this, we'll get mu mmg plus kx by 2. What is the value of minimum value of f? F will become minimum when you substitute kx equal to how much? Mu m2g by 2. Sir, if it is a smooth, if m2, if the friction between the block m2 and the ground is 0, tell me in that case, what shall I write? I should apply force greater than mu m, because when m2 will shift, when spring force is non-zero. For the spring to get elongated,